Okay, I see people are still joining us, but I'm going to get started just so that we can stay within time. So just really wanted to welcome everybody. Thank you for joining us for our second webinar in our three-part series. I'm Sandra Meidinger. I'm the manager of the Environmental Division in our Edmonton office, and I'm going to be your facilitator for the webinar series. Since we're on a virtual platform with staff and guests calling in from various locations, I'd like to begin our webinar by recognizing the Indigenous peoples of all the lands we're on today. In Canada, we acknowledge the ancestral and unceded territory of the First Nation, Métis, and Inuit peoples. I want to acknowledge and extend my appreciation to the Indigenous peoples of all the lands we're on today in this virtual environment. So as some of you know, our webinar series follows a fictitious linear development project in Northern Alberta. Last week, our audience learned about the complex regulatory processes involved with this type of project. Today, our speaker, Brent Schmidt, will walk you through how we would assess for the potential for contamination within the same project area. Brent is a geoscientist with over 12, or sorry, he has over 10 years of experience in contaminated sites and remediation. He's our go-to in our office for all things contaminated sites. Brent spends as much of his time outdoors as possible, whether it's fieldwork, camping, hiking, or skiing in his spare time. When he isn't outside exploring, he can be found at heavy metal concerts. He recently went to Las Vegas to see Tool, and in September, he'll be in LA to see Rammstein. Brent has been with us for 3 years. His commitment to quality work, project organization, and client communication has been instrumental in helping us expand our contaminated sites practice in Edmonton. So with that, I'd like to hand it over to Brent for his presentation.
Great. Thanks, Sandra, for the introduction. So our second webinar, we'll be discussing environmental site assessments and how it can be an important part of your project for planning purposes. So this presentation will go over what's considered contamination, project due diligence, owner liability, general overviews of the site assessment process, and tie them into a fictitious case study that was introduced in our first webinar by April. So what is considered contamination? A site is contaminated if the concentration of a regulated substance is greater than an applicable environmental guideline that protects human and ecological health. In Alberta, environmental quality guidelines are sourced mainly from the Alberta Tier 1 and Tier 2 soil and groundwater remediation guidelines. For sediment, vapor, other jurisdiction standards, such as BC's, may be used. Otherwise, a project could fall back to federal guidelines published by the Canadian Council of Ministers of Environment or Health Canada. Soil grain size and different zoning and land uses also affect the guidelines used. Typically, the most stringent to least stringent land uses are agricultural, residential parkland, natural area, and commercial industrial. Although there are guidelines to protect different receptors, the guidelines shouldn't be used as pollute up to values. If certain contaminants are above natural background conditions, they could also be considered contamination. And that comes into importance of why environmental site assessments and having a professional assess the site, as many times there are certain metals and parameters that have a guideline value but may actually be not of concern. Sources of contamination can be gas stations, automotive repair, dry cleaners, industrial facilities. So that's a wide range of items, but pretty much any type of production or industrial site is potential. Fire training facilities, heating oil and fuel, spills of many sorts of chemicals, landfills, dumps or nuisance grounds, roadways and maintenance yards, well sites, wastewater treatment plants and lagoons, airports and fuel caches. And so this, the list is never ending, more or less. So it's always a potential there, possibly, unless you have a perfectly undisturbed area. There's always something that could potentially be a contaminant source. So many times contamination is not visible at ground surface, especially if the source of contamination starts below the ground from leaky drains, pipes, or tanks. Many times there won't be a sheen on the water or black stained soil at ground surface to know that there are impacts at your site. Contaminants can migrate with surface water flow, or precipitation can infiltrate into the soils that are contaminated and eventually leach into the contaminants into the groundwater. The dissolved phase of contaminants will not be observed. Only when a contaminant has saturated media does it become more visible. Metals and salts, even at ground surface, will likely not be easily seen or have an odor, and requires a laboratory analysis to confirm those concentrations. So how do you know if your property or project area has an environmental concern or potential impacts? So here's a list of questions that you might want to ask yourself when starting a project or have a site. So is there known historical contamination activities on or adjacent offsite? Do you know the history of your project area or of your property? Has there been underground tanks or pipes that have been forgotten about? This is more common than you think, of people not knowing about this history of a site. Have old buildings been demolished? Was there any undocumented spills? And was a project area undeveloped greenfield site, or appears to be? So a lot of times overgrown vegetated areas on a property may be hiding something underneath the vegetation and ground surface if it hasn't been touched for decades. Vegetation will overgrow it, and then once you start opening it up, surprise, surprise, you might find something there. So in many cases, an environmental site assessment is required by banks for property transactions or government regulators, depending on the project type and where it's being developed. But not all projects require those ESAs. However, if the ESAs are not conducted beforehand, there may be problems later on, such as project delays and extra costs, if that contamination is found during construction. So due diligence of understanding the environmental conditions of your project area before getting too far in help mitigate those potential problems. So for example, if a contractor excavates and hauls contaminated soil to a new location or pumps off water that is contaminated, then the project may be liable for the remediation costs to clean up the receiving location where those contaminants were deposited. So a lot of this can be avoided by knowing beforehand what your site conditions are and if you have contaminants, and having a plan in place before. So who is responsible for the remediation? Essentially, it's the landowner, persons, or party who caused the impacts in the first place. However, it may be difficult to know exactly who caused those impacts. There are also occurrences when the responsible party is unknown or are no longer around, or if a company can't afford the remediation. Then it could become responsibility of the new owner, possibly the government. You are not responsible if you acquired a contaminated site and you undertook all appropriate inquiries into the previous ownership and uses of the site and undertook other investigations consistent with good industry practices at that time in an effort to minimize the potential liability. But you will still need to have an agreement with the responsible party to cover the costs and liability if they're known. So buyer beware. Do what you can before it's your responsibility, and understand your liability if a property is contaminated. This goes for larger civil projects as well, such as roads, pipelines, etc. If the conditions aren't known before construction, then you may be liable for managing the cost of the impacts. It could also possibly mean full remediation or partial remediation with an agreement in place with the responsible party who pays a portion of that cleanup. The biggest thing here is that this can only be started if you know beforehand if you have a problem to begin with. So let's move on to the types of environmental assessments and their importance. It's important that potential purchasers and financial institutions know the environmental liability associated with a property prior to purchase. Projects big or small could run into historical contamination or cause their own if not properly managed. So this diagram shows the typical flow of environmental site assessments and remediation and what a typical single lot property could go through. We'll go into detail of this process on the next couple slides for the phase 1 and phase 2, and then introduce our case study. For linear infrastructure projects like roads, remediation may not be feasible or cost effective. At this point, a contaminated sites management strategy may be prepared with recommended soil and water management. The contaminated soils management strategy is then provided as part of a tendering package to contractors so they are aware of the impacts and can plan their scope and estimates accordingly. In addition, if there is significant impacts found, Alberta Environment and Parks may be contacted to get approval for the contaminated sites management strategy and approval for the beneficial use of waste, which otherwise means reusing the soils on site that may be contaminated as long as it's not doing additional harm to the environment. So when should the environmental science assessments be started on your project? This slide shows where the environmental team should be included, which as you can see is throughout the entire project lifespan, including the proposal stage, and also be included in the client's request for proposals. Environmental's role will vary from project to project depending on the contract and if it's with the landowner or a contractor as a client. So let's go through the types of environmental site assessments required. We'll start with the Phase 1 ESA, or what we sometimes call the Contaminated Sites Overview, depending on the project. A Phase 1 ESA follows certain standards and has a list of certain record searches and databases required, along with conducting interviews with people that have knowledge of a site. For larger linear projects that cross multiple properties, this may not be a feasible method. Therefore, either a modified Phase 1 ESA or Contaminated Sites Overview may be conducted that remove some database searches and interviews that may not be applicable or feasible to conduct. These initial assessments do not have any sampling involved. They're only for identifying potential and known areas of concern and potential contaminants such as hydrocarbons, salts, or metals. In some instances, though, the Phase 1 ESA may be conducted with an initial sampling program or a Phase 2 ESA if it's a remote site or it's known that a Phase 2 ESA is required regardless of the outcome of the Phase 1. Phase 1 ESA should be conducted whenever there is a property transaction or changes to the site. Many times, a Phase 1 ESA might only be valid for a year, depending on the changing site conditions. In other cases, such as an undeveloped greenfield site, such as a forested area or an agricultural field, a Phase 1 ESA could be valid for up to 5 years. But after a year, Phase 1 ESA update is required. After 5 years, a whole new Phase 1 ESA should be completed. So let's introduce the case study that April had discussed previously. So a town wants to build a bypass road off the highway to reduce traffic through the town. The proposed road goes through a First Nations reserve, a closed landfill, and across wetlands and a creek. There are several stakeholders involved in this project, including the First Nations and Indigenous Services Canada, the province, the county, and the town. Known contaminated sites before the project started include the closed landfill and an abandoned well site. So during the feasibility stage, a contaminated sites overview was conducted to understand the project area conditions, history, and flag any known or potential areas of concern. So a 300-meter radius search was conducted for historical reports, documents, and databases to look for items such as fuel storage, well sites, pipelines, water wells, etc. During the search, a remote drilling waste disposal area, or a sump, associated with the well site was found, as well as historical information of an old gas station. Both are located within the proposed roadway. Highways and roads are also identified as areas of potential concern due to the use of road salt, which can impact soils and vegetation growth. During the site inspection, it was noted that the landfill has existing groundwater monitoring wells that are regularly monitored. So we'll just kind of go through each of the apex and kind of the list of items. So landfills, that's the main one. And there is a ton of different parameters that could be a concern here, depending on the type of landfill and the waste that was deposited. So salts, metals, hydrocarbons, those are all the easy ones. The hydrocarbons can also include PAHs, which are polycyclic aromatic hydrocarbons, which are the carcinogenic hydrocarbons for the most part. Volatile organic compounds, so those are lighter and vapor producing type contaminants. Dioxins and furans, those are a byproduct of burning. PCBs, which are polychlorinated biphenyls, so those are in certain oils and transformers for older type electrical transformers and electrical items. Pesticides and herbicides, this is a lot more common in rural dumps around farming and agricultural areas. PFAS and PFOA, which is an emerging contaminant that's is a wide range of parameters that are associated with firefighting foams and frying pans, anything that's kind of water repellent and are becoming a quite concern. And then the landfill itself, depending on how old it is, landfill gases and methane could be emission and many more. For the old gas station, the list isn't as extensive. So depending on how old this gas station is, lead in the gasoline could be a concern. The hydrocarbons, obviously, dioxin and furans, if there was an old shop nearby, could have been some burning taking place. PCBs again with electrical items and greases. MTBE, which is methyl tertial butylene. It's also a byproduct of that can be found in gasolines. The drilling waste disposal area, the main concerns usually are salts, metals, and hydrocarbons for it. And then the roadway, metals, hydrocarbons, and salts could be a concern. So quite a wide range of contaminants that could be a possible concern on the project area. So now that we've identified our apex and the potential contaminants of concern, we move into a phase 2 ESA to characterize the project area. This involves a collection of soil, groundwater, and surface water samples for laboratory analysis. Results of the laboratory analysis are compared to the appropriate regulatory guidelines, including factoring in soil grain size, land use, and neighboring land uses. Based on the results, it may be recommended that no further action is required, or it may be determined that further work is required to delineate the contamination. Environmental site assessments reported to the Alberta government end up on the Environmental Site Assessment Repository, or ESAR, which can then be used for future ESAs and phase 1 ESAs when you're looking for those documents of nearby environmental reports. Under the Environmental Protection Enhancement Act in Alberta, spills or identified contamination must be reported. And note that the initial phase 2 ESAs are for characterization and only, and that contamination delineation may not be achieved in the first round, nor is it typically the main objective of the phase 2 ESA. It's just for understanding if you have contaminants and then following up with either a supplemental phase 2 or what's sometimes called a phase 3 ESA to focus on the contaminants identified and delineating those, and also providing some additional site characterization. Depending on your site, different jurisdictions may have different guidelines. Many do cross-reference each other, but typically for sites not under federal jurisdiction, the generic go-to guidelines in Alberta are the Alberta Tier 1 Soil and Groundwater Remediation Guidelines. The Tier 1 guidelines are the most stringent and take into account all exposure pathways for human health and ecological health. And minimal site information is required, typically just the land use and neighboring land uses and grain size if you have it available. Otherwise, you just go with the most stringent value between coarse grain and fine grained. So back to our case study. During the feasibility stage and after the contaminated sites overview is complete, a phase 2 ESA is conducted focusing on the identified apex to characterize soil and the groundwater conditions, as well as confirm the presence of potential contaminants. For this scope, the phase 2 ESA is based on the road design with a focus on the depth of the excavations required for the road construction with thorough sampling to understand the soil quality of the soils that are going to be handled. The phase 2 ESA can also be used at the same time to assess the topsoil depths for later salvaging. And around the apex, you could have some deeper boreholes and monitoring well installations to fully assess those particular areas. It's not needed. Monitoring wells are likely not needed for the entire length, but maybe as such, we've proposed some around the old gas station. The landfill, because there's already monitoring wells there, in this case study, no additional monitoring wells were decided that were needed. For a roadway, a set interval may be selected for sampling to represent a certain volume of soil being managed, and it's usually on a project by project basis. So for example, it could be one constant sample representing every 500 cubic meters of soil, or it could be for every 1,000 cubic meters of soil, 2,500. 2,500 cubic meters is usually the max that we'll collect for a sample. Otherwise, it's too much volume to not enough characterization. Parameters being sampled will be dependent on the contaminants of concern and may not be necessarily analyzed at every location or sample depth. Typically for a roadway, depending on the conditions, salts and metals are analyzed throughout the entire project area, as there could be naturally occurring salts and naturally occurring metals, and we want to have a good understanding of what that is. If it's an undisturbed area, hydrocarbons and other exotic parameters are probably not needed to be analyzed, or anything that's a refined product. If there's no need for it, then we don't need to sample it off in remote spots. Those efforts will be focused on where it's needed, such as at the landfill, the drilling waste disposal area, or the gas station in this case. It's also recommended that background soil and groundwater samples be collected to determine if the guideline exceedances that are found are naturally occurring or an actual contamination concern. So in this case, there are a number of undisturbed areas within the project area that we considered as background. So we don't need to go off the project area to find the background. For sites that have groundwater monitoring wells, typically a site needs at least 3 to properly assess groundwater flow direction, and they need to be reasonably close together. You don't want a site, and in this case, we're going across a few kilometers. You can't have monitoring wells that are kilometers apart. It doesn't. You can't use that type of data. It's more so within a maximum, usually 100 to 150 meters apart is the maximum extent where you can have monitoring wells. So that in this case, this phase 2 ESA will likely require multiple trips to the site for initial drilling, and then the well installs and development, and then follow up groundwater sampling, just depending on the groundwater recharge of the site. If impacts are identified, additional delineation may be needed. And again, the objective of the phase 2 ESAs is characterization, not delineation. So in this case, we've done the drilling and we've come back and found that there is some exceedances using the generic Tier 1 guidelines. So exceedances were identified at the landfill and old gas station, which is more or less expected, and near the highway. Luckily, the drilling waste disposal area came back as non-environmental concern and everything had passed there, which usually is not the case, but in this case it is. Sampling of the existing monitoring wells at the landfill indicated the groundwater exceedances, that there were groundwater exceedances compared to the generic Tier 1 guidelines. And then comparing the results to the generic guidelines, several locations that were not suspected to be impacted had elevated selenium metal exceedances. So in this case, through the reserve portion, this was undisturbed area and we were not expecting exceedances, but we did find some when comparing just to standard guidelines. So now we need to assess why that is. Are they naturally occurring? Are they actual impacts from something else that wasn't identified during the phase 1 ESA? Are the guidelines too stringent being used because we're going through several jurisdictions? Is it the provincial or the federal guidelines too stringent? Is there nearby receptors that are not applicable. So this all comes with importance to review the data and understand the site and if there's actually a concern. So in this case, we looked at the data and it was determined that the nearby receptor, so the creek that's throughout the middle of the project, is greater than 300 meters away from the reserve lands, and that the guidelines were bumped up to be higher, was remove those previous exceedances that were identified. This, although this means that the most stringent guideline was protecting the creek, but it was greater than 300 meters away, so therefore it's not as much of a concern, and therefore the guidelines were able to be bumped up. The groundwater exceedances that were identified at the landfill were determined to be naturally occurring elevated metals based on review of historical reports, and then therefore deemed not a result of the landfill activities, and therefore not an environmental concern. However, there are still soil exceedances from the buried waste, and there's still the potential for landfill gases. The old gas station remains with an environmental concern with possible hydrocarbon plume going towards the creek. All this information is then used to prepare the contaminated sites management strategy that's going to be applied for this project. So contaminated sites management strategies are used to summarize the environmental site assessments and identify areas of environmental concern that contractors must be aware of. It outlines recommended soil and water management for those areas, and other items that we typically include are stockpile management and sampling frequencies, what areas of soil that need to be hauled away to a landfill that may not be acceptable to keep on site, and what to do if there's unexpected contamination found. Since we're only had samples every few hundred meters apart, there could have been something that was missed in between. So the contaminated sites management strategy is provided as part of the tender package with the construction specifications. The contractors are then aware of the environmental concerns, both for health and safety planning and for determining their costs of their bid. The contaminated sites management strategy can also be presented to Alberta Environment and Parks for approval for beneficial use of waste, which is a policy to use soils for other purposes, such as for commercial roadway construction, as long as it doesn't do additional impacts to environmental receptors. On a regular type site, instead of the contaminated sites management strategy, delineation would likely be conducted and then either remediation or risk management options reviewed and then executed through a remediation action plan or risk management plan. And then for ongoing construction monitoring, environmental's role will be determined as part of the tendering as to who is responsible for environmental management on the project. So that could be either the owner or the contractor. Typically, the contractor will be responsible for managing the environmental components, including the soil management and sampling, with notifications provided to the owner. However, in some cases, the owner may want to have their own representatives on site to monitor the work as it goes on. So that ends the presentation on environmental site assessments. A reminder that our third and final webinar series is next Tuesday and will be presented by Brent Baudou. His presentation will go over the fundamentals of pre-construction wildlife sweeps and include a discussion of the potential outcomes and mitigation measures that might be employed. We hope you sign up and join us next week. Any questions?
Thank you, Brent. So while everybody's thinking of their great questions, Brent, I'll just ask you, if you had any buildings within that study area, would those need to be assessed as part of the project?
Yeah, if there is buildings, houses, shops, old commercial buildings, if there was some within the project area that were going to be demolished, then yes, it would likely be recommended, depending on the age of the building, hazardous building materials assessment be conducted, and that's going in to take samples of the paint, insulation, tiles, and just looking for if there's asbestos, lead-based paint, mercury, and then those items will then have to be abated during the demolition process.
Great, thank you. We do have a question from Jessica. She asks, are there any permits or regulatory approvals required for environmental site assessments?
Typically, if it's on private land, you shouldn't need it. But in this case, in this project in particular, we're going through a couple different jurisdictions. So just to bring it back up, the First Nation Reserve, we would be consulting with the nation and with Indigenous Services Canada to get the go-ahead and approvals there. For the provincial areas, typically we would get a TFA or temporary field authorization to conduct the work with the drilling.
Hopefully that answers your question, Jessica. April, oh goodness, I'm going to say your last name wrong, my apologies. April Renberg. April asks, phase 1 ESAs expire between 1 and 5 years. Is that regulated or is that best practice?
It's definitely best practice. Within the city of Edmonton, within their ESA guidebook, it is for redevelopment of areas. A phase 1 ESA is only valid for a year, then a phase 1 ESA update is required. Otherwise, if it's over that 5 years, a brand new full-on ESA is needed. So we typically run that as our best practice as well.
Wonderful, good question. Scott asks, why is the search rate, ooh, I lost it. Why is the search radius limited to 300 meters?
So the 300 meters is the typical standard that's used. The CSA standards requires a minimum of 300 meters. We can go further away for those searches, but the 300 meters is based on a hydrocarbon contaminant plume. Usually its maximum extent of that could be of concern is 300 meters, hydraulically down gradient. So that's what we typically use. We can expand it out, but usually it's just extra data and information that is likely not relevant to impact the site or the project area.
Great. Karma asks, if there was evidence of a current or former livestock operation along the route, would that be an APEC? And the second question is there a criteria for the age, size, intensity in order to make it an APEC?
Yeah, so in that case, if there was a livestock operation, it probably would be identified due to the manure and extra nutrients that are going into the systems. It's similar to fertilizer runoff. So if there's any dugouts or nearby creeks or receptors, there is a potential that those are being impacted by that. In the say the project area itself, say if there was a livestock area in this particular case, sampling would be conducted through that livestock area to understand if there's loaded nutrients like ammonia or nitrates and or salts potentially that need to be handled separately within that project. And then is there criteria for the age, size, intensity in order to make an APEC? Understanding the APEC it's more of judgmental than it is. It's just understanding your site history, what are the potential contaminants, and what the uses of it are. So it could be big or small. An APEC could be as small as a burned out car or a vehicle that has some soil standing underneath it or a heating oil tank to an entire industrial site.
Okay, and Cassandra asks, if we find contamination in our ditch and can't find the source, are we liable for all cleanup costs?
And it's technically, yes, if the contaminant is leaving your property or you're managing it. A lot of times it may be that the contamination that's going to be handled is part of the project, and the remainder may keep in place. It depends on, it's very project by project and the intensity of it. There's been a lot of projects where for roadways within an urban setting, if there's an old gas station or a shop or something that had contamination that went off the property and into the roadway, it may be that a partial remediation is done. And again, it's if you know beforehand and can find out who was responsible for it beforehand, then that can be addressed. Otherwise, you may be most likely responsible for the cleanup.
Great questions. We are going to move into our draw for today's prize. So I'll have Audrey get our wheel of names going. And if you see your name on the screen, we will contact you. We have your email address, and we will contact you to get you your prize for attending today. Gary, congratulations. I can't wait to find out what it is. I don't know what it is myself. Okay, so please keep entering in your response. As Brent said, we have our last webinar on April 12th, and that will be Brett Boudreau, and he'll tell you all the things you need to know about wildlife and bird nest sweeps prior to construction. And thank you, Brent, for the great presentation today. Thank you, everybody, for participating in the polls and asking your questions. We really appreciate your participation today. And if you have any feedback for us, we'd love to hear from you. So, and thanks again for joining.
Thank you, everyone.